Hello, everyone. We continue from our previous lesson. So now we will be going into problem solving number 5 or example 5. Okay, under belt and pulleys. So here we have the question. A ladder belt, don't look at this first. A ladder belt is required to transmit 7.5 kilowatt from a pulley 1.2 meter in diameter, running at a speed of 250 revolutions per minute. The angle of embrace or the angle of lap or wrap is 165 degree, and the coefficient of friction between the belt and the pulley to be 0.3. If the safe working stress, here now you have the stress. Remember, stress is equal to force over area. The force that we refer will be the tight side tension, the maximum tension. Okay, so if the safe working stress for the leather belt is 1.5 megapascal, and the density for leather given is 1 megagram per meter cube, that means it's 1000 kg per meter cube. To SI unit is kg, so you have to put 1000. Now the thickness of the belt is 10 millimeters. Now determine the width of the belt by taking centrifugal tension into account. So you will be including the TC or the centrifugal tension. So this will be the pulley and this will be the centrifugal tension. Okay, so these are the given datas: the power, the diameter of the pulley, the speed of the pulley, the stress, the density, the thickness, the coefficient of friction. The width is unknown, width to be determined. Okay, so first of all, you have the speed, okay, omega, the angular speed of equals to 2 pi n over 60. The n given here is, where is the n? 250 revolutions per minute. So convert that to radians per second. That's why you times 2 pi divided by 60. So this is the tangential velocity or the belt velocity. Velocity of the belt. Okay, so is given as r omega. So the r and the omega are referring to the same pulley. Okay, but then now here in this question there's only one pulley given. So r is the radius, where the diameter given is 1200. Convert this to meter is 1.2 divided by 2, so is 0.6. So the omega we got is 26.18 radians per second. So the tangential velocity or the velocity of belt is 15.71 meter per second. And the next is the angle of lap. So they have given us the angle of lap is 165 degree. So that actually refers to this angle here. Okay, so from this point here where the belt is about to leave the pulley, and also at this point here, so this angle, this projected angle here is called the angle of lap or the angle of wrap, that is given by theta. So they have given us 165 degree. Okay, 165 degree, which is the angle of lap. So convert to radians, so you divide by 180 times pi, or you divide this by 360 times 2 pi. So you get 2.88 radians. Then to the power transmitted, okay, so the power given is 7.5 kilowatts, so is 7,500 watts. So this T1 here is the tight side tension, and this is the slack side tension, the belt velocity, and this is the number of belts. So from this formula or this equation here, actually you can change it into this form, which or when you take TC into account. So the TC minus TC minus, so when you minus this minus sign here, when you multiply it into the bracket, so you get a plus, minus TC plus TC, actually a TC will goes off. But then we are writing it in this form because we are making use of the belt tension ratio later. Okay, so which are unknown for the time being. So you have this is equals to 477.4. So how you got this? Take 7,500 divided by 15.71. So you will get 477.4 Newton. So based on the belt tension ratio, which we include, okay, the TC, where we include or we are taking into account of the centripetal tension. One thing. Second thing, when you refer to the belt speed, this speed here is 15.71, which is greater than 10 meters per second. So therefore, we have to take TC into account. So because the question doesn't state that it is V belt or flat belt, so we consider this as a flat belt by taking the ratio here as equals to E mu theta, where mu is the coefficient of friction, theta is the angle of lap, which we have found 2.88. So we got this ratio here as 2.373. So manipulating this, bringing the T2 minus TC over the other side, so you have this equation. So from here, we got to know that T1 minus TC is equals to 2.373 T2 minus TC. So you can substitute this into this equation earlier for this part here, T1 minus TC. Okay, so you will get 2.373 T2 minus TC, then minus T2 minus TC equals to 477.4. Don't break the bracket, don't break up the bracket yet, okay? So you will get, okay, from this minus this, you will get 1.373 bracket T2 minus TC, 1.373. Okay, so then when you divide 477.4 with 1.373, because why is 1.373? Because this is 2.373 minus 1 here. This is a 1 here. So it becomes 1.373. So bring it over. So you have 477.4 divided by 1.373. So you will get T2 minus TC is equals to 347.71 Newton in terms of T2 minus TC. And this one would be T1 minus TC equals to 825.12. How you got this? So because from here, you got your T2 minus TC already. Substitute 3471 into this. That means multiply by 2.373, you got this value here. Then the next, the mass per meter length. Per meter length, because the mass for belts is being counted as kg per meter. Okay, the unit is kg per meter, unit measurement for mass per meter length. So therefore, when you look at the density is 1000 kg, this is 1 mega, so it's 1000 kg multiplied by the cross-sectional area of the belt. The belt is rectangular, flat belt is rectangular. So you have the thickness multiplied by the width, where the thickness is given as 10 millimeters, so that is 0.01 meter. So from this, you will get 10 times of width. The mass is 10 times of the width. So once you got the mass, now you can substitute the mass, which is 10B, to the TC equation. That means to the centripetal tension formula here, which is rho AV squared or MV squared. It can be either equals to rho A V squared or MV squared. So your M is 10B, and the velocity that you have got earlier is 15.71 square. So you got 2468.04 multiplied by width Newton. So from this earlier, what we have got T1 minus TC. Now we know the TC with this value, substitute here. Taking T1 minus TC and not T2 minus TC, because T2 minus TC is the minimum value. T1 minus TC is the maximum value. So you always consider based on when you design, based on the maximum force. That means based on the maximum tension. So since we know the TC, we substitute TC here. So we got this. So manipulating this, okay. So you got T1 is equal to 825.12 plus 2468.04B. Now we know that they have given us the stress 1.5 megapascal. So remember times 10 to the power of 6. Stress here, the direct stress, the stress on the belt is a direct tensile stress. Force over area. Stress is defined as force over area. So the force that is the maximum is T1. So your stress with this area we got earlier, that is thickness times width. So this is the stress. So you got T1 in terms of B here. So once you got this, substitute this value here for T1. So you will be able to find out the width of the belt is 0.066 meter. Okay? Thank you. For example 5. We will continue to example 6 later on. Thank you. Bye. Now, we continue from the previous example 5. Now we have example 6. It's still in belt and pulley. Yeah. So example 6. Now determine the width of a 9.75 millimeter thick leather belt required to transmit 15 kilowatt from a motor running at 900 revolutions per minute. Now the diameter of the driving pulley of the motor is 300 millimeter. The driven pulley runs at 300 RPM. You see there's a driving pulley and a driven pulley. So you take a look at the driving pulley speed is 900 before reading the whole question now, yeah? The driving pulley is having a speed of 900 and the diameter of the pulley is 300 millimeter. So that means this pulley should be smaller because as you compare, this speed is higher and this speed is lower. So the one with the higher speed, usually the diameter of the pulley should be smaller. The one with the lower speed, the diameter should be larger. Okay, but in this question, they did not give us the diameter of the larger pulley. And they given us, sorry on my voice, and then they have given us the distance between the center of pulleys is 3 meters. Now the density of the lead is 1000 kg per meter cube. Then the maximum allowable stress in the leather, this is the direct stress, 2.5 mega or mega Newton per meter square or MPa here. The coefficient of friction between the belt and the pulley is 0.3. Assuming that is an open belt, this is an open belt, and neglect the slip of the belt. Okay, so this is an open belt drive. Okay, so the diameter of this pulley is 300 mm, but the speed is 900 revolutions per minute. So the diameter of this pulley was not given, but then the speed should be lower, that is 300 revolutions per minute. So these are the angle of lap here. You should have another one, that is the angle of lap. But then both the angle of lap should be the same, geometrically. Okay, so these are given data. So the question doesn't give us the larger pulley, right? So we can use this the speed ratio, diameter to speed. So remember, they are inverse. So if you write d1 over d2, you must write n2 over n1 here. If you were to write d2 over d1 on the left-hand side, then on your right-hand side, you should have n1 over n2. Okay, so since the subject is d2, because we want to find d2, so d1 multiplied by n1 over n2. So you have the diameter of the pulley. This one is 900 millimeter or 0.9 meter, where the size of the smaller pulley is 300. Okay, so to find the angle of lap, as you notice that there is no angle of lap or wrap that is given in the question. So we can base on the geometry of the figure, which on the previous lesson, which I have already taught you how to find out angle of lap in case if they are not given, based on the geometry of the figure. Okay, so you can refer back to that. So from this, you can find out the angle of lap of 168.52 degree. Remember, convert this to radians. Okay, convert this to radians in the later part. So the next one is, of course, the belt speed. We don't know the belt speed. So if we want to find the belt speed, the first thing is the angular speed. Okay, so where n1 is 900, because you are looking at omega 1. If you are looking at omega 2, then here should be n2 and 300. The value that you get should not be the same. Only the tangential velocity is the same. If the tangential velocity is the same, v1 and v2, then omega 1 and 2 will not be the same if you want to find omega 2 as well. But then no need, because the belt speed is based on either v1 or v2, either one. So since you are looking at pulley 1, so you need only to find the v1, which is also equals to v2. So that will give you the belt speed or the tangential speed, which is greater than 10. This question, again, you must consider this centripetal tension or the centrifugal tension. So that is the angle of lap. You convert this to radians, degree to radians. Then again, based on belt tension ratio, this is again a flat belt, because with width and thickness, that means it's a flat belt. So the mu and the theta, coefficient of friction, and the angle of lap. Okay, so you found out this equation here, but then this time instead of T1 minus TC, okay, T2 minus TC previously in terms of T1 minus TC, right? Now here I'm just playing it around, okay? So T1 minus TC in terms of T1 minus TC. So we know that power transmission, okay? So you can write in this form, into this form, or in this form. So because we are taking TC into account, so we wrote it. So from here, you can see, okay, now what I need to substitute is T2 minus TC. So replace this T2 minus TC here with 0.4132 TC. Okay, so you get everything, you will be getting everything in terms of T1 minus TC. Okay, T1 minus TC is equals to 1807.81 Newton. Now TC, which is equal to rho AV square. So you have this. This is the other way around of the previous problem. Okay, the previous problem they didn't ask you to find the diameter and so on. Okay, so TC. So the same thing. Okay, the stress is given. Okay, we just substitute stress, and then the thickness, the width is unknown, so you got T1, and then put it into the TC into this equation, and when you solve, you will be able to find out the width of the belt. Okay, so all these manipulating work, okay, you must know by now, because these are simple mathematics. So you will be able to find out the width of the belt for this question. Thank you for staying with me. This is example 6. Thank you very much. We will continue with example 7. Thanks. Bye. The third example, that is problem solving number 7. Okay, example 7. Now, an open belt drive connects two pulleys, 1.2 meter and 0.5 meter diameter, on parallel shafts. Okay, so 4 meter apart. The shaft or the pulleys, they are 4 meter apart. Now, the mass of the belt is 0.9 kg per meter length, so it's 0.9 kg per meter, and the maximum tension is not to exceed. So this is T1, 2000 Newton. So the coefficient of friction is 0.3. The 1.2 meter pulley, which is the driver, remember 1.2 meter pulley is the driver, runs at 200 RPM. So due to belt slip on one of the pulleys, the velocity of the driven shaft is only 450 RPM. So this is 200, larger pulley, 400, larger speed, so smaller pulley. So calculate the torque. Now this part here, they ask you to calculate torque. So that is on the pulley, not on the belt. Okay. So the power is 2 pi Nt over 60 for the pulley. For the belt is effective tensions times velocity. So this power transmitted here is based on the pulley. Okay. So and the power loss in the friction, they ask you to calculate the torque on each of the two shafts, then the power transmitted and power loss in friction, and also the efficiency of the drive. So these are both the pulleys. So this is denoted as pulley 1, which is the driver. This is denoted as pulley 2, which is the driven, running at 450 RPM. Then this is running at how much? 200 RPM. So these are the given datas. Okay, so the pulley, the diameter of the pulleys are 1.2 and 0.5 actually. Okay, so the center to center distance, this is the mass, 0.9 kg per meter, actually is per meter. So the T max, that is T1, is 2000 Newton. Here they consider T max, okay, is equals to T1 plus TC. But then, okay, you can solve the problem by taking this as T1. Okay, so this is the other approach, the other way of approaching solving problems with TC. Okay, so it is either way from the previous ways of example 5 and example 6. You can use example 5 and example 6 way of solving example 7. Okay, so they ask us to find the power loss and the efficiency, the torque, okay, on T1 and T2. Now there are two T here. One T is based on tension, the other T is based on torque. Yeah. So the speed convert to radians per second. So we are taking based on this pulley here. Okay, so that is 20.94. So the belt speed is 12.56. So you can use V equals to R omega. That is the tangential speed as well. So remember, these both are referring to 1, subscript 1, that is the larger pulley, the driver. So this is to find the angle of lap. Okay, so you can convert degree to radians, which is 2.97. And this is a belt tension ratio. Now you take a look at this. The velocity here is greater than 10 meters per second. So you should take TC into account. This is the other way of approaching or solving the problems, okay, by considering T1 over T2 instead of T1 minus Tc over T2 minus Tc equals to E mu theta. Actually, you can use both ways, okay? So Tc is equals to mv square. M is mass kg per meter, so this is the speed. So here, this is what I meant. T max here is T1 plus Tc, okay? So if you don't want to use this method straight away from the beginning itself, the belt tension, you can consider T1 minus Tc over T2 minus Tc equals to E mu theta. Okay, so and then you use the steps that we have solved problems or examples on 5 and 6 to do it. Okay, so what they have found here is the T1, which is 185802 Newton. So they take base on this should be 2.44, yeah. The belt tension ratio should be 2.44 here. Okay, so you got T2, you got T1 and T2. Both of these are belt tension, yeah. So the power transmitted by the belt can be found by this. So this is 13.77, that is the input power, yeah, on this pulley here, the input power, okay, the power input. So the next part is to find out the torque. So remember, the torque definition of torque is tangential force multiplied by radius. Torque means tangential force multiplied by radius. So the tangential force that we refer is the tight side tension and the slack side tension. That is the effective tension. So that's the tangential force multiplied by the radius based on larger pulley. The torque transmitted by the larger pulley is this. So based on smaller pulley, then you have to consider R2. So torque transmitted by the smaller pulley, so still the effective tension, but this time you are looking at the radius of the smaller pulley. So you got a torque of 274.14 Newton meter. So you can see that is the difference. There is a difference between the torque transmitted from larger to smaller pulley. So based on this, you can see means that there is a loss in power transmission because this is the driver and this is based on the driven. So based on angular speed, now we are not looking at the power based on anything that is moving in straight line like the belt. Now, when you refer to the pulley, the power should be 2 pi nt over 60. But then you found that this power transmitted, the power input, sorry, this is the power input by driver, is 13.78 kilowatt. And as compared to the belt, based on the belt, we have 13.77 and this is 13.78. So that means it is almost the same on the pulley and on the belt. Okay, based on the belt is 13.77 kilowatt. Based on the larger pulley, which is the driver, you got 13.78. Okay, so the difference is only 0.01 kilowatt. That doesn't make any difference. So that means it is proven that the power input is that much, is 13.78 or 13.7. Then the power received by the smaller pulley, you can also use 2 pi nt over 60 because smaller pulley is also a rotating component. So you can take this. Remember, power can be found by effective tension times velocity times number of belt. That is based on belt. If you take based on pulley, you must use 2 pi nt over 60 or T omega. So that is the difference. So this is based on the power input and this is on the output shaft. This is based on the input shaft, that means the larger pulley. This is the output shaft, the smaller pulley from the previous diagram. So if you take the difference, you will be able to measure the power loss is how much when you are transmitting power from larger pulley to smaller pulley. This is the amount that is which is lost. This is quite an amount, okay, as compared to the 0.01 just now. So efficiency is defined as output over input. So your output power is this, and your input power based on the driver. Output is based on the driven, input is based on the driver, output is based on the driven. So you got the efficiency of 93.76%, which is quite high. Okay, thanks a lot for question 7. That's all for question 7. Thank you. Stay safe and bye. Okay, example 8. Now, in a flat belt drive, the initial tension is 2000 Newton. The coefficient of friction between the belt and the pulley is 0.3, sorry, and the angle of flap on the smaller pulley is 150 degrees. Now, the smaller pulley has a radius of 200 millimeter and rotates at 500 revolutions per minute. Find the power in kilowatt transmitted by the belt, not the pulley. Okay, so this question is quite direct. Okay, so these are the given data. This is the initial tension. The initial tension is denoted as T0. Okay, tight is T1, slack is T2, and T0 refers to the initial tension, 2000. So initial, based on the definition of initial tension, is equals to this. There's tension between the tight and the slack. Okay, of the tight and the slack, not between, of the tight and the slack. So you have this. And the speed is 2 pi n over 60. So that will give you the angular speed of 52.36 radians per second. So belt speed to r omega. So the radius of the pulley, that is the only one, 0.2, and the speed of 52.36. Therefore, you can find out the belt speed of 10.47 meter per second. So in this question, basically, you don't have to consider TC, okay, even though it's slightly greater than 10. So the angle of lap is 150 or 180 times pi, so it's 2.618 radians. So based on belt tension ratio, and to form the equation of T1 in terms of T2, okay, so from this, you can have 2.193 T2 plus T2 is equals to 4,000 Newton based on the initial tension equation. T1 plus T2 equals to 4,000. So where T1 is equals to this, 2.193 T2. From here, you will be able to find out T1 and T2. That means basically you are using both of these, 1 and 2, to find out the unknowns of T1 and T2. So from very direct, you can find out the power transmission. Okay, thank you. That's for example 8. So we will move on to example 9. Thank you. So a belt is 200 millimeter wide and laps a 600 mm diameter pulley by 170 degrees. Now, if the maximum permissible tension, that is T1, is 12 Newton per millimeter width, they are giving you T1 as 12 Newton per millimeter width. So if let's say you take this 12 multiplied by the width, let's say 200 here, you will be able to find out the T1. So that will be 2400 Newton. Okay, and the coefficient of friction is 0.25. Calculate the power transmitted when the pulley rotates at 240 revolutions per minute. This is another very direct question. The only things, this statement here, okay, this statement here, which you have to understand what it is stated here. So the width is 200 mm, diameter, angle of lap, that is the stress, the maximum tensile stress, 12 Newton per millimeter width. So we have the width here 200. So if we take 12 times 200, you will get 2400. Okay, so the coefficient of friction is 0.25. So we have to find the power. So firstly, deal with the T1, the tight side tension, which they have given you 12 Newton per millimeter. So this is actually not the stress. This is the tight side tension. Okay. So this speed, 25.13. By now, you should know how we got this. And the belt speed. Okay. R omega, where radius is 0.6. And the angular speed is 25.13. Okay, so the tangential speed is less than 10. So we must not take TC into account, especially this question is less than 10. Angle of lap, okay. Then the belt tension ratio, flat belt, because with width and thickness, we will be able to find out the T2. So after that, the last part is the power, okay. So by now, you should know the power transmitted by the belt. The pulley is, by pulley is 2 pi nt over 60. That one you have to calculate separately between the larger and the smaller. This one is based on the belt itself. Pulley. Now, if the maximum permissible stress, now this is stress, okay, of 5 Newton per millimeter square. Now calculate the power transmitted when the larger pulley rotates at 450 RPM. Calculate the power transmitted when the larger pulley transmits at this speed, taking coefficient of friction as 0.3. So these are the given data. So this is the speed, okay, converting 450 revolutions per minute here into radians per second. Then the belt speed, V equals to R omega, 7.66 meter per second, which is also lower than 10. Okay, then the angle of lap into degree, this is an open belt. So for cross belt, this will be a plus. Then after that, you have to take 1260 minus the theta. Okay, so this is a flat belt, open drive. Okay, so you got an angle of lap of 174.6 degree and in radians. Then this is T1 by taking stress multiplied by the area. This is the stress given as 5 Newton per millimeter square. If you convert this, it will be equivalent to 5 mega Newton per meter square. 5 Newton per millimeter square actually equals to 5 mega Newton per meter square. So it's 10 power 6, the stress, and this is the area. So you'll be able to find out the tight side of 2000 Newton. So once you have found out T1, then you can go for T2. So based on belt tension ratio, so that's your T2, okay, 801.51 Newton. Then you can find out your power transmission, 9.18 kilowatt. This is example 10. Then we will continue with example 11, and the rest of the example, you just take note, okay, when would be the premier for what 11 and 12. That's all for example 10, and we continue with example 11. So this is example 11. Now a belt drive consists of 2 V belts. Now this is not flat belts anymore. This is a V belt in parallel. Now 2. So the quantity of belts here is 2. The N is 2. And then it's not flat belt anymore. It's V belt on groove pulleys of same size. So the pulleys are of same size. Pulleys of the same size. So take note of this. If pulleys are of the same size, the angle of lap theta can be straight away taken as 180 degree. that is pi radians if both pulleys are of size. Now they have given us the angle of groove, which is beta 30 degree, which is 2 beta, 30 degree. The cross-sectional area of each belt is 750 millimeters square. They have given us a cross-sectional area for V belt as 750, so we don't have to bother about the dimensions. So the coefficient of friction is 0.12, and the density of the belt material is 1.2 megagrams per meter cube. So it's 1,200 kilogram per meter cube. The maximum safe stress, that is the maximum direct tensile stress, 7 meganewton per meter square. Calculate the power that can be transmitted between pulleys of 300 mm diameter rotating at 1,500 revolutions per minute. Find also the shaft speed in revolutions per minute at which power transmitted would be maximum. Okay, so these are the various cross-section of belts. This is a flat belt, so the pulley that they use is flat surface. So for V belt and for circular belt, usually you use groove pulleys. Or if you have belts in this type of belts, you usually use multiple groove on pulleys. So these are basically the 4 different types. So when you refer to V belt, where it requires a V groove pulley, so this is a V groove on the pulley, yeah? V groove on the pulley, and the groove angle here is given as 2 beta. So if beta, then it is half of this. So they have given 30 degree. 30 degree is based on 2 beta. So therefore, beta is 15 degree. Okay? So we just solve the problem in our S, the usual way. Okay? So these are the given values and the speed. By now, you should know. Okay? And then the belt speed, which is more than 10 meters per second. So you have to take TC into account in this case. So we can find out TC where rho given A given V is found, the tangential velocity. So we can find out the centripetal acceleration straight away, 501.3 Newton. Then the angle of flap, remember they say the pulleys are the same size. So usually same size pulley angle of flap is 180 degree. So that is pi radians. So, and then based on the stress, okay, so you will be able to find out the tight side tension 5250 Newton. Based on the belt tension ratio, the difference here is the cosecant beta. Remember, cosecant is taken as 1 over sine. So this is 15 degree, yeah? This is degree, okay? 1 over sine, cosecant is 1 over sine. So that means it's 1 over sine 15, okay? So that is the coefficient of friction. So you got the belt tension ratio 4.291. So then from here, you will be able to find out your T2, because you have already known your TC and T1. So you'll be able to find out your T2. So power transmitted is given by this formula by the belts. Okay, this is by the belts. So you substitute your T1 and T2, the velocity of the belt, and the number of belts here in this case is 2. 2 V belts. Okay, so the power would be 172,000 watts or 172 kilowatts. Then the maximum power transmitted. So remember on the previous section when we are dealing with power, maximum power transmission. Okay, so first thing we consider centripetal tension. These are the cases which I have listed out. Okay, when to consider the centripetal tension is equal to T1 over 3. Okay, you cannot take this under normal conditions. Only for maximum, you can consider TC is 1/3 of your tight side tension. So which is 1750. Remember, this is under the condition of maximum power transmission. So, and also the Vmax formula. So you can find out the Vmax, okay, because TC is equals to rho AV square. Okay, TC equals to rho AV square. So the V would be equals to Vmax. It's the same as this, your TC. But then this time here is the Vmax, because this Vmax is unknown. So you have to first find out the Vmax before you can find out the power max. So once you have found out the Vmax, just substitute into the power transmitted formula for Vmax to find out the power max. Okay, so the Vmax should be 44.1 meter per second. Okay, so that's the speed. Okay, 2807 revolutions per minute. That is the speed in revolutions per minute. Okay, so from this, okay, you will be able to find out the speed 2807. Thank you. That's all. Bye bye. See you on next lesson. Stay safe. Yeah, thank you. Bye bye.